super excited to bring together experts from TiDB and Milvus, two prominent names in the field of distributed and vector databases, respectively. First off, from Zilliz, we have James. James is the VP of Engineering at Zilliz. He has extensive experience as a database engineer at Oracle, Hedwig, and Alibaba Cloud. James played a crucial role in developing HBase, Alibaba Cloud's open source database, and Lendom, a self-developed NoSQL database. Ed is the co-founder and CEO of PingCAP, one of the creators of TiDB distributed database and the TiKV key value store. While he was at Vandu Labs, Ed worked on clustering Redis and created an open source Cordis, a proxy-based high-performance Redis cluster solution. During the next 1 hour, we'll take a deep dive into TiDB's distributed databases vector search engine, as well as Milvus's dedicated vector database. Our speakers will showcase the capabilities and benefits of both vector database and distributed databases with vector search engines built in. After that, and you will love this, there'll be a no-holds-barred panel discussion comparing each other offerings, pros and cons. And this will be a very interesting discussion where both James and Ed will go man-to-man against comparing why each of the solutions are better. And then we conclude with the Q&A session. We look forward to answering all the questions that you have from you. So overall, this 1 hour will be very crucial for anyone involved in building AI applications, regardless of project size or complexity. So at this point, let me hand it off to James. James, nice to meet you.
Sure. Thanks, Kai. So hi, guys. I'm James, working for vector database for the last 3 years, build open source Milvus, also working on Zilliz Cloud. So today get to share some experience about how we build Zilliz service, and also some happy to discuss VectorDB together with Ed. Yep. Okay.
James, do you want to present your slides, or do you want us to present it?
Okay, so yeah, sure. Give me one moment. Okay, so today I want to quickly share about Zilliz service, which is our latest progress. So before I get started, so some quick background about vector search and why it is necessary. So yeah, so I know a lot of audience, you guys are trying to build RAG applications, agent memories. Yeah, upon those applications, search is definitely one of the most important part, and is going to be a headache. You can definitely use traditional search like Elastic, like Lucene-based all search, but they're actually 3 major drawbacks. One is you lost context. When we want to search for Apple, we don't know if it's a food app or it's a MacBook, right? So we also lost some kind of semantics because for different keywords, it could be like looks like very similar, but the actual meaning is going to be very, very different. So for example, if the example I gave, they have like totally different words, but actually same kind of meanings. Yeah. Third is that you actually lost user's intention, right? Sometimes when we search for change car tires, we definitely search some of the website about how to help you to search car tire. But problem is sometimes we're more like looking for details about like pricing, about or some specs for the tires, right? So there are some like user intentions. So that's why vector search jumps in. So when we talk about search, I think VectorDB is one of the part, right? So you definitely need a vector search with semantics. You definitely need to think about multimodality, what kind of embedding models you're going to use, rankings. And it's definitely not only about RAG. It's actually a complicated agent. So when we talk about AI power search, you should have a very complicated process, right? How to extract data, how to chunking, encode your data, indexing, retrieve, re-rank, summarize, generation. So it's actually a very long journey to build a very qualified AI search. Yeah. And to make sense even worse, right? So not only you have to build a qualified search, there are also like a bunch of things you have to worry about. What is the cost per user? You definitely don't want to like pay $100 per each user if you're trying to build a consumer application, right? How to monitor the system, like how to handle multi-tenancy, how to handle burst traffic, when you get locked, right? Your application get really popular, how to handle that, and a lot of availability issues, how to scale, how to be performant. Yeah, so that is ideally a real world AI powered search we try to build on the cloud, right? So it's going to be very, very complicated. So we definitely don't want to explain it unless you have like a lot of details to ask. But generally speaking, you have some kind of data source, using some kind of AI models and also a ETL process, turning it into tags and embedding vectors, and then put it into vector DBs. On the right side is actually architecture for Milvus. It's actually very, very complicated. So a lot of users, they just try to deploy it by open source, but it's going to be very hard to understand and maintain. Right? So that's why we build Zilliz Cloud. Yeah, and we define it as a vector DB for busy engineers. So we have open source side. We have Milvus. We have actually a light version, which is called Milvus Lite. So you can quickly deploy on your laptop. So it helps you to do some POCs, help you to modify your algorithms. Then when you put into production, you definitely want to migrate everything to the cloud, right? You can either pick this cloud or our BYOC version. So this cloud is more like managed versions. You don't really need to worry about everything. And if you also have security concerns, try BYOC. And it's going to be ready on off the cloud, right? So with this cloud and Milvus, you can easily test your code on either your laptop or on your GPU notebook, and you're running it on your production environment. It can be easy to scale. You can quickly deploy with one single API, and you have a lot of different index solutions that is definitely want to benefit when you want to pick a vector DB, and it definitely can integrate with a lot of popular large language model stacks like LangChain and Llama Index. Yeah, and what's even easier? That's why we introduced serverless, which is vector search for only APIs, right? So a lot of users told us that when we call large language models, right, although it's going to be very, very complicated, I know OpenAI did tons of optimizations on their large models. We don't really need to worry about it, right? So it's just a stringing and answer out, right? So we want to build the same thing. That's why we have the serverless. Right, with like 3-4 lines of code, you can easily build a vector search without even worry about how you can scale, what the performance is, how you manage the cost. Everything is actually hosted by us. And yeah, what's more exciting is that compared to traditional way you use a vector DB, it's actually have 10 times cost saving. It can support a large scale, so it can be the largest deployment be done is like 10 billion vectors. So it's like hundreds of nodes, and you don't really need to worry about this. We handle all the performance issue, and it can deliver you 100 milliseconds search latency, right? So behind the scene, it's actually a large cluster. So with a lot of logical clusters, so each user is actually a logical cluster, share very large physical clusters. We have a lot of polling resources and dependencies. So it looks like it's going to be very, very hard to maintain, but it's actually our duty helps you to make sure that everything works smoothly. And you should only worry about how you can call in those APIs and verify the search call, the search result. Yeah. So if you take a deeper look behind the scene, right? So why it's going to be super cheap, especially for RAG applications, because you're going to have a large amount of data. Elastic becomes really, really important. Cost becomes really, really important. Yeah, the reason behind the scene, right? So First thing, I think we have tera storage. So traditional database, vector DBs, you just put everything into RAM. That makes your life very difficult if you have a large amount of data, right? Because on the cloud, each gigabyte of RAM costs like $5. So we actually have tera storage. So unlike other competitors, we have both RAM, we have SSDs, we have EBS, and we have S3, right? So we put hot data into RAM, some relative frequent data onto SSDs, and all the cold data into S3. So that helps you to save a lot of cost. That's also why our storage cost is all kind of like comparable to S3 rather than comparable to memories. Right. Second thing is the distributed cold and hot data. So as the graph on the right side, so hot part of your data or active users is usually like very small amount of your whole data, right? So we put hot data on local SSDs and cold data on to S3. That saves like 90% of your savings cost. Yeah. Third thing is like using global index instead of using a local index, right? For all the other vector DBs, we like kind of like focus on optimize one single index on a single machine, right? But for those serverless is actually a global index. So the actually vectors index is across all the nodes. So when search happens, you don't really need to do search on each of the segments and try to do reduce. And we actually have a smart program policy help you to save a lot of traffic. Yeah. And last but not the least, for every serverless, it's actually very elastic. So you don't really need to worry about the cost you never use. So it's actually the pay-as-you-go model. Yeah. And for now, it's actually already beta on GCP. And it's going to be generally available by the end of this month. And the price is going to be very, very, very cheap. So if you guys have any questions about serverless, have any questions about how to make your serverless, how to make your vector DB a little bit easier, I'd like to talk about this more, right? Thanks.
Thank you, James. And you can take it away.
Okay, sure. And find my screen. Can you see my screen?
Yeah.
Okay, perfect.
Yes.
Yeah, thank you, James. Basically, I'm really glad that you have already shared a lot of details and the architecture, and 101 for vector search. That is the basic. That basically what I'm going to share. So, yeah, today my sharing is about TiDB serverless and TiDB's vector search. I use a very interesting title. TiDB serverless is all you need. I wish you guys can bring up some can understand what I'm going to talk about. TiDB started from the general purpose database. We started build this database like 10 years ago.
Ed, sorry to cut you. By the way, we're seeing your
Screen?
seeing the screen, but we're seeing the browser where you're sharing the agenda. Not the slides.
Okay. Can you see?
Now we see the slides.
Okay, nice. Awesome. And yeah, this is the title. TiDB serverless all you need is it's like a contribute to the attention is all you need. So just like I said, TiDB started from a general purpose database. We started like 10 years ago, and with some MySQL compatibility, so that in the early days we built TiDB just want to solve the scalability problem of all the traditional SQL databases. But today I'm really glad to say, hey, the vector search and the AI application becoming more and more popular. I think as a general purpose database, we need to embrace this trend that's why we are using a different approach instead of building another new vector database, but we introduce the vector search capability into the kernel of the distributed database like TiDB. So I'm really glad that James mentioned about the cost. So that's why we introduced the vector capability into TiDB Serverless first, because what can be better compared to low cost? It is free cost, zero cost, right? So we actually introduced the the free tier for all the TiDB Serverless users. You can try the TiDB vector with up to 25 gigabytes free storage, and also TiDB vector, TiDB serverless, and the TiDB vector search in serverless can actually relies on the solid foundation of the TiDB core. That means you can scale out to like unlimited scale. I put the 1 million QPS here, but actually you can scale even more. So, and the TiDB Serverless is a pay-as-you-go, use a pay-as-you-go model. So you just like James mentioned, it is a serverless product. You don't need to worry about provisioning the infrastructure or maintaining all the like complicated software. So all you need to know is only the MySQL endpoint and the connection stream. So yeah, basically they have a lot of different interesting and features with TiDB. And today I'm going to, rather than introduce by the using the slides, but I want to do it in the more interactive way. So this is a very quick example that TiDB how TiDB support, how from the user's perspective, how users can use TiDB with its vector index, vector search support. So basically we can just create the table with your SQL statement and insert the vector data into using insert into statement like the traditional way to with SQL. So it's showtime. Okay. I'm going to start it with the TiDB Cloud. Yeah, this is my account. So can you see my browser here?
Yes.
Okay, nice. Yeah, basically you can just log in the TiDB Cloud with any browser. This is my dashboard, but you can easily create a new cluster within a couple seconds. For example, I'm going to create a new serverless cluster like TiDB vector add. And you can see here is forever, it's free, and you don't need to worry about the biting your credit card. No need for that. And you can see here we have a beta version of the vector search support here. You can check the box here, create a new cluster. So and this is the now we wait like 20 seconds and you'll see the yeah, the cluster is ready. Okay, so you can find that you will have the connection stream here, and let's try copy and copy paste. You can see you can just use the MySQL client to connect it to TiDB serverless with vector support. So I want to share my terminal so that you can see better. Okay. Let's try to use this. Okay. You can see I have already connected to the cluster I just created. I prepared some SQL statement. For example, create a vector table, insert some vector data into that, and try to query. This is the quick starter. Like, let's see. Okay. You can see that's quite easy, blazing fast. And there's another quick demo I want to show is here is an example that really show the how powerful TiDB with the vector support is. For example, this is this SQL statement or this three table schema comes from the real world use case. So in the old days, we normally separated the article the document separate the document and their vector index in different databases. For example, you store the original document or original article in S3, but the vector data stored in different vector database like pgvector or Milvus. But if you can see this demo, we can actually create the raw data table for the article and chunk table for the chunk for each chunk within this table. And also we can have an embedding table all together in the unified platform and unified database. And what's the most sweet thing is that you can easily join and retrieve the data within one SQL query using like the join statement, like the old days. You can actually query the vector data using the vector index to do some semantic search and join the original data with your of your original article or original document. So that is very powerful. And don't forget that TiDB is a distributed database. We don't have an upper limit on how much data we can store. We can easily scale out. So that means you can store billions, the rows, billions of documents within the single unified TiDB cluster. And it is very powerful. Besides that, and I also want to share the what else we can do with the TiDB vector, because I think the API will be a very important way to operate with to build AI applications so that we provide let me share my browser back. Where is my screen? Oh, I have so many opening window. Desk 2, okay. Yeah, can you see my screen now?
Yes,
Okay,
I can
nice.
help Edge.
Okay, yeah, you can see we just like I said, we think the API is a very important way for the user or developers to build AI applications, so that we also provide the TiDB vector in the Python SDK, so that you don't need to actually write the SQL. You can just use the Python code to operate with TiDB serverless and vector search. And also we built some very interesting demo about how to build like the knowledge graph or the integrate with other AI framework like Llama Index or LangChain using TiDB serverless. You can see here is an example to use the TiDB vector search with LangChain to build a knowledge graph of the Wikipedia data. So I'm not going through this code line by line, but the point I want to say is you can see from this source code, we don't actually need customer or the user to write actual SQL. And it is very convenient for the Python or AI application developers. So yeah, that's basically what I want to share. Last but not the least, I want to share another demo called TiDB.ai. It is the real world example and it is public already. So it is built on top of TiDB serverless vector, and it is a typical RAG application. All the data are stored in TiDB with TiDB vector storage, and we integrate this with OpenAI so that create a small chatbot to answer the question about the TiDB. For example, I want to ask a question. Does TiDB support JSON? How to build JSON index? And it's actually not directly asking question to ChatGPT, but instead we retrieve the data from TiDB's vector search and use that data as the context and send it to OpenAI's GPT API to generate the final result. So you can see that actually creates the correct answer for my question. And what's the cool part is this is the knowledge graph within TiDB how to answer this question. So all of this fancy demo we have already open sourced and it built on top of TiDB. So yeah, that's what I'm going to share. Thank you.
Thanks, Ed. Right on time. Awesome. Hey, keep the questions coming. I saved all the questions. We'll answer them during the Q&A time. Right now, it's time for panel. This is the one that I promised where both the panelists will be very open. This is not a scripted answers or anything. And obviously, I've had the questions, but the answers will be very open. So the first question that I have is for James. James, you talked about vector database and the amazing value that it provides, right? My question is, if database developers already have to struggle choosing between, hey, based on my workload, should I choose Postgres or MySQL, NoSQL? And if I choose one of them, which particular database to go and so on? So as a developer, do we need now yet another, like a vector database specifically? What would your answer be for such a question?
Thanks for the question. So yeah, I'll actually be working in the database industry for more than 10 years. I'm actually a big fan for Postgres. I worked for Oracle when I was a new grad. So and also worked for a couple of distributed databases, NoSQL, SQL database. Big fan for PG, big fan for TiDB as well. I did a lot of set programming with TiDB. So yeah, I think it's this round of AI applications is pretty much very similar to what happens on MongoDB 10 years ago, right? So people are trying to build mobile applications. Right now, people are trying to build AI applications. They really need a fast way to build their applications. It's unlike traditional applications, right? For MongoDB, it's all about schemaless, right? All about faster development without concerning about how you can do concurrent DDL, how you can do transactions. Currently, it's going to be very sim. For regular applications, users don't really want to worry about transactions. They want to do very quick semantic search. They don't want to use ES search because actually I like ES search, right? The search results are pretty good, but they also take a lot of time to do knob tunings to how we can find the right tokenizer, how we do all the parameters, right? So vectors is just the easiest way for like all this, right? And also from technical perspective, I thought AI native is actually going to be very, very important. So we all talk about distributed database. I think it's pretty good that Ed and I at least have something in common, right? Serverless. So we all think serverless will going to be the future. So yeah, and there's a bunch of trade-offs when you build vector search. Yeah, definitely transaction databases, right? Like TiDB, zero peak transaction consistency. But for vector search, right, we have different trade-offs, right? We work on distribution of data. We don't really need to worry about 100% accurate. So that gives a lot of room to improve the performance, improve the cost, and make things easier to use. Yeah, that's why I think VectorDB for now is going to be very, very important, especially when you have large use cases. Yeah.
Ed, do you have any rebuttal for that, or what would your answer be for that question?
To me, today we have so many different databases. We have cache, like Redis. We have NoSQL. We have different kind of. It is really hard for the enterprise to choose. So that my dream is, I think in the future the direction will be the architecture should be easier and easier from the user's perspective. It is the direction. So that's why I'm thinking the unified platform is all we need. And also from the user's experience today, I think SQL is still the best thing we have that can provide the flexibility, and also the everyone knows SQL. So that to me is more like vector database is very, very important, I think. And this scenario is very important. The semantic search, because and the vector search is very important. But it could be that would be easier that you can use the vector search or the vector feature in your database you have already using. So this is basically what we are going to do in TiDB. Yeah.
Yeah, I actually have one comment
Awesome.
about the SQL part. So yeah, I'm actually the SQL guy. I build a lot of SQL databases, and when I started building VectorDB, I am really, really astonished to find that all the developers, they are like Python developers, Node.js developers, but traditional like SQL databases is going to be Java, Golang, very traditional languages. So it's still going to be a gap. So I like SQL, but I think Pythonic is going to be very important as well.
Agree, totally agree. That's why I'm thinking, in the future, maybe the database vendor should provide the SDK or interface for different languages. I think Python is very popular today, but I think in the future the community will be more diverse. But how to easily, but another feeling, my gut feeling today is most of the AI application we are building now is more like a creative application, or like to me, it's more like a demo. There is not the killer application. Only killer application today in AI community is ChatGPT, and yeah, right. So, that's why I'm thinking maybe in the enterprise in the future, I will definitely there will be the enterprise ready AI application. But at that moment, the requirement for the databases could be will be a little bit different today, right? So today we are most of the vector database or other database, the enterprise feature, the security, multi-tenancy, a lot of things we need to consider in the enterprise scenario. So that's why I'm thinking maybe in the future, the most challenging part is not the vector index itself, but other, enterprise feature or enterprise capabilities like security, compliance, everything else, like the database, traditional database today. Yeah. So
Awesome. So that's a good first question then. And the second one that I have is, Ed, now that I have you, maybe let's start with you. Do developers that are building AI applications even care about the underlying database, or is it abstracted to a level enough that they're agnostic to what database they're using and they just care about the outcome? What do their care abouts look like?
yeah, just like I said, today all the application AI developers only care about the SDK and the Python API. So to me, I don't think they really care which database they are going to use. They just follow the documentation in the Langchain or Llama index. What's the database they recommended? So, but I think there is a very important insight under this, because application developer always want to, today's developer, they always want to choose the easiest way for the fast onboarding. So the ease of use will be the key today. That's why I think Zilliz and including TiDB Serverless, we are doing a great job in made the onboarding experience smooth. That's why we are all providing the serverless tier. Yeah.
James?
Yeah, actually, like most likely agreed what Ed said, right? But yeah, I thought it's kind of like depends, right? The answer is yes, because if they have a lot of requirement, right? So they really need to worry about what database they're gonna use. But the answer is also no, right? Because if you're using long chain Llama index, it's also like vector DB agnostic, right? So it's a very simple interface. Right. I think someone asked Andrew G like what kind of vector DB you're using, and his answer is NumPy. So you have only 10K vectors, right? It doesn't really matter what things you're going to use, right? Or a lightweighted version should be great. Using serverless should be great as well. Yeah, but they have large amount data. If they have like very complicated semantics, right? If you want to do group by on the vectors or on your scalar data, probably you need a relational database like TiDB. If you want very high performance, you probably need a vector DB like Milvus and yeah, and a scalable solution. So it's do really depend on what kind of applications you're trying to build. And for now, since most applications, as Ed says, just like demos, so it might not be that important. But when you try to put into productions, you definitely need to like distinguish between all the different vector DBs.
Yeah, agree.
Yeah.
Got it. Awesome. For the next question, right, I have, we can do like a quick rapid fire type of answer. When choosing which specific database to choose among, whether it's a vector database or a distributed, SQL database with vector search engine, what are some of the characteristics that developers need to care about? And I have 5 written myself. If data scale is important, which one do you think is perfect? Either one of you can start.
Actually, from the data scale perspective, I think in the near future, the AI application, for each user, the personal data will be a very important data, personal data. But the data size of the personal data is not that big. But if you are going to provide the database service or imagine that every user will have their own vector index, vector database for storing, indexing their own personal data. It is not that big for each user, but the sum, the total amount of the data could be really big. So that from the database developer perspective, this question is yes and no. We need to handle the data scalability problem if you want to provide the platform or service. But from the user's perspective, the total amount of data, the scalability is not the big problem for them. Yeah, this is my opinion.
James, what do you think on the data scale?
Yeah, we definitely have like I think their data scale in the list, cost in the list, yeah, index type. But from my perspective, I thought most important going to be easy of use. Yeah, as I just said, because most users most likely they are trying to build POCs, verify their algorithms and also the process. So easy integration is going to be very important. Easily you can bring up a cluster. You don't really need to maintain everything by yourself. That is definitely the first choice, and that is also the first lesson we learned, because we try to build everything on the Kubernetes, and we soon find that user complain a lot about this. We don't really need to worry about scale at that time, like back to 1 year ago. But right now, like we do see a lot of scalability issues when user already have existing solution, but they find that is going to be a huge trouble, especially when you want to build a consumer applications. When you have 100 consumers, each consumers have 10K vectors, sounds to be really good. But when your application grows, when you have like 100 like million level users, then it becomes a big headache. Each user have like 100K vectors. Then you add up all of them together, it's gonna be 100 billion. That'll be huge, right? And by that time, then cost become really important issue. Even security become really important issue. Yeah, but from day one users, I thought easy of use and search qualities is actually what is very important for our users.
Yeah. So James, as I have you, how about the retrieval performance? I know you mentioned when you're covering the Zilliz, the slides, you talked about performance being high. For retrieval performance, when someone building a RAG search application, what do you think is better, like vector database, or will a distributed SQL database be fine for more common use cases?
Yeah, so that is a good question. So, yeah, we've been working on a lot of optimization on the performance. We do see some use cases, yeah, but it's more like very traditional use cases like recommendation systems. Last month I have a conversation with a very large AI application company, and when we talk about performance, the answer is anything less than one second will be good enough. Yeah. So the reason is large language model latency is going to be high, and the overall end-to-end latency is usually 6 to 7 seconds in their use cases. So they don't really need to worry about it, especially on latency side.
Yeah, I totally agree, because today benchmarking the latency or from the vector database, it only have a very little impact on the end user's experience, because today the LLM itself is the bottleneck. It is not the database. Yeah. So
Awesome. My third question is on the cost side. Each of you individually have mentioned that, hey, with our architectures or using different types of tiered storage, the cost is pretty less expensive, right? But James, if you start looking at the components that you start adding as part of the stack to build a RAG application, right? You're looking at some kind of a document retrieval, some kind of chunking tool, Then you have developers obviously to stitch all these together, and then you might need a vector database and you might need a regular database. So the costs start adding up. So what would be your answer for someone when they say, hey, your individual cost might be low, but the overall cost is increasing because of the tools? What would your answer be to justify why a vector database is needed from the cost perspective?
Yeah, well, actually, that is a good question. A lot of users like do worry about the cost, right? So I think the first thing is, even for vector search itself, you have to optimize the cost in many ways. One of the ways as I just mentioned in my slides is tiered storage. So as all those traditional databases, you definitely don't want to build only a cache, right? Put everything to memory. Yeah, but that is the most likely what happens on current vector databases. They just put every index into memory. Yeah, and under that situations, that cost will become big problem. So yeah, and that's why you need to put everything on the disk. You need to use quantization algorithm to reduce the data size. Yeah, and also, yeah, we've seen a lot of users, they want to put original data, not only vectors but also images, but also their text chunks into a system. Yeah, I thought that is, I also agree that put everything into one system make much more sense. So from one side, traditional database, traditional like databases, they try to have all the vector search functionalities, and from the other side, vector DBs also try to add a lot of scalar filtering, a lot of retrieving functionalities, so they can be working more like a database. Yeah, agree on that.
Yeah, so to me, it is like reducing the cost is like it is not the not the very specific problem for the vector search or vector database. I think it is for a general database, it is also the like the everyday job for the database developer today. So that is why I'm thinking, you know, in the short period of time, we introduce our vector search support and with a very low cost, because we have already built a solid foundation of in TiDB. Yeah.
Cool. So I have 3 more questions, and then we can go to the Q&A. So when you talked about the speed, where, okay, the retrieval performance is not the key thing, but the LLM itself, you know, their speed is, you know, in like seconds, so that dictates, that is the main bottleneck. How about the quality of this, you know, search? That's when someone queries, what's the quality of retrieval results look like? Is there a difference between what a vector database might show or what a regular database with vector search engine? Is there one that's better over the other in terms of the quality of the results?
Yeah, I will leave this question to James, expert.
Yeah, the answer is yes. We'll be working on a lot of optimizations. Yeah, I saw TiDB will probably finally working on those optimizations as well. First thing is that dense embedding is not enough. That is what we found. So most of vector DBs, we are still supporting dense embeddings, but a lot of users, they do hybrid search, right? They have multiple way to do retrieval. As I just said, for the TiDB AI, they have these knowledge graphs. That is definitely another way to do RAG, right? So what we do right now is we support all different kind of embeddings, not only dense embeddings but also sparse embeddings, covert. So in that way, you do multi-way retrieval and you try to do a ranking that can greatly improve your search quality. And also there are a lot of other like way to optimize that as well. Like if you're trying to tune the index, try to optimize the graph quality, that is definitely something you can do to like optimize the search quality. Yeah, but I think one thing important is that embedding itself still dominates. So I think the most important thing is still going to be choose the best embedding models and generative models. That is like far more important than anything else.
Yeah, 100% agree on that. You know, I think as a database vendor or a database provider, we only provide the capability for the storing, retrieving the data. But how to build you know, create embedding, how you organize your data within the database, that is the key part for, you know, high quality, generate high quality result. So yeah.
Cool. So just switching gears a little bit and zooming out. So here we are, two database vendors talking about each other's offerings. If you look at the larger ecosystem, right, there are two camps. One who say, hey, I have this great framework, Llama Index or LangChain. I'll find the best of breed products within that fit within this stack, and I'll build the amazing AI product on top. That's one camp. And the other camp is like, hey, this is all too complex. Just I'll try to find RAG as a service vendors who will abstract away all the complexity and provide you like an API. Like how should developers think choosing between one or the other? Any thoughts on that?
I think it is like the different level of abstraction. You know, some if you want to build a quick demo, maybe using the end-to-end solution like a RAG as a service, only click the button and 5 minutes later you can build your first application. The experience is good, but when you want to build something serious or some enterprise, or you need more flexibility or more control of your application code, maybe the API framework, SDK, databases, that will give you more flexibility and to build your application. So my opinion or my attitude on these two is not like one or another, but it's more like you know, different products will be good for different scenarios or different purpose. Okay.
Yeah, agreed. I thought it's also kind of like based on your use case, right? So if you are a company trying to build reg applications as your core business, right? You are building a search, then I think you have to build from scratch. You have to pick your embedding models, rankings, know all the tricks. They have to control all the logics, right? So, but if you are a web page designer, you just need a chatbot, or you just need to build a search box on inside your web page, but it's not your core business, then I would just recommend you use a RAG service because it's going to be very, very quick, and you don't really need to worry about anything about this. You just focus on your own business. Yeah.
Cool.
Yeah.
So last question, and we may have covered this, but so you just coming back to vector database and database with vector search engine. In what situations is choosing vector database a better option, and vice versa? In what situations is upgrading a traditional database with vector functionality more suitable? Maybe if there's one takeaway that we want developers to walk away with, what would that be?
Yeah, so I actually want to answer the on the opposite side. So what is the scenario I'm going to use TiDB Serverless or TiDB vector search? The answer is if your data is already in TiDB, and then if the performance is okay for your like applications, you should stay and put all the data in one like system. That make your life much easier. You don't really need to maintain consistency between multiple databases, multiple systems. Yeah, and also if you really need to process all the scalar data, you need joins, you need aggregations. That is probably another signal that you want to put some of your data in, like your vector data into VectorDB as well.
Wow, thank you for promoting TiDB. And I want to also want to promote Milvus on my side. You know, sometimes the vector database can have the flexibility on defining the query interface and how user to you know, interact with the vector data. and it is really have the flexibility that to optimize for the extreme scenarios like the performance, super low latency, and that reminds me Redis, right? You today you are using Postgres or MySQL, but for the cache scenario, you need sub-millisecond low latency. Redis is still dominate the market. So I would like to say Redis is a great example that the specific database, just like better database, is really good with some specific scenario. But if you just want to need a general purpose database, TiDB is all you need. Yeah, that's the point.
Awesome. Thank you both. Now we can get into the Q&A. We have some interesting questions lined up. The first one is, can we filter vectors based on metadata fields associated with each vector? And also, like that's the first part of the question. And then the second part of the question is, and also which algorithm, like face or NI, etc. Like, what do we use internally to fetch similar vectors?
James?
So yeah, I can take this question first. So yes, I think most of vector database right now support filterings. There are a couple of ways to do filterings. One thing is do pre-filterings, which is you do filterings on scalar data, then you search based on the filter result. Yeah, and the other way is post filterings. You do search first, and then you filtering on the top key result. So I think pre-filtering is actually most vector is actually using, and yeah, and today since the reg application become really popular, we see a lot of more high-level filtering requirement. So we've been working on filtering on JSONs. We've been working on filtering on arrays. Yeah, I thought maybe traditional database is more powerful on that use cases. Yeah, and unluckily, none of the vectors index support the filterings. We'll be working on with the fast team to support filterings. So I think today you have to use like vector DBs to support the filterings.
This question is exactly the reason why I think introducing the vector capability and vectoring the index into the traditional database, that is a good idea, because the filtering or the secondary index, they are already there. For this question, you can just only create the index for your data. You are all set. You don't need to even need to worry about to do the extra filtering on your vector data. So yeah, that's the that's why I want to say. Thank you.
Cool. So I think the second question is more of a comment, but maybe you can expand on it. Storing large object data into the table will be heavy on I/O. Like, how do we handle this? How do each of you handle this?
I can start it with how TiDB solve this. Because in the original design of TiDB is aimed at to solve the problem of scalability for most of the OLTP scenario, like millions of read and writes for small single-digit latency with transaction support. So we use a share nothing architecture. You can consider we can distribute the workload across different nodes, different machine. That's basically how we handle the heavy traffic and the heavy workload, because we are designing for this kind of scenarios.
Yeah, so yeah, we'll be working on the opposite way. So Milvus is more like a storage computation distribution. So we heavily depend on S3. So all the large blob values will be just directly stored into S3s. So for Milvus itself, we just store reference. So it's gonna be easy for us. We don't really need to worry about the large blob values. Yeah.
Cool. So the next question is, do both Zilliz and TiDB have Java-based database connectors?
Which question? Let me see. Java-based. I don't see this question. Is it in the chat box or?
Yeah, it is in the Q&A part in the open questions.
Oh.
Or we can get to that because that can be answered through text too. Let's go to the questions that need discussion. So the next one is, does TiDB has inbuilt memory to restore frequent data like Redis?
Yeah, we have we can leverage the memory as a cache. But it is not directly exposed the memory API or to the application developer. So yeah, this is like TiDB is designing purpose is like still want to build a database with data. We can support data persistent data in the disk. The cache is only used for speeding up for the read. Yeah. Okay.
Got it. James, this is for you. Do you see vector search? Do you think vector search will supersede traditional keyword search, or will a hybrid solution gain more popularity?
Yeah, I will see. I believe that both dense embeddings, which is good for like semantics, and also sparse embeddings or traditional keyword search is actually they'll be both exist for a long time. But I think for keyword search, it's gonna be very different from what we have right now. Because if you look at what Elasticsearch or what Lucene is doing, is that they are still using a lot of stats. So based on the corpus, what the corpus is, they do tokenize, they do stats calculation. But what we believe is both keyword search and the semantic search will be based on large language models in the future. So yeah, so it's going to be very different, but they'll be existing for a long time.
Got it. Dinesh, I think this question you can answer through text about the competitors. Okay, the next question is, based on benchmark results, is there a specific vector dimension that works best for speed and accuracy?
So the question is, there a specific vector dimension for like a good trade-off between both speed and accuracy? Is that?
Or maybe your recommendation or suggestion on which embedding algorithm is good for the speed accuracy. Yeah.
Yeah, I would definitely say OpenAI, right? So and
Yeah,
and
me
the good
too.
part for OpenAI is that they can truncate the vector embeddings. So it's kind of like based on your accuracy needs. It can be large, it can be 3K, it can be also 15K, and you can just truncate it to 384, and it's still gonna be working. You lost a little bit accuracy, but it's still working. Yeah.
But the trade-off would be the cost. A little bit expensive compared to other solution, I would say. Yeah.
Yeah, I mean for open source, BGE is gonna be my favorite. Yeah, I know like
nice.
different people have different.
And maybe a
Okay.
question for you. I guess one of the developers wondering, hey, eventually all database products will come up with vector database capability or vector search capability and able to search vector DB search functionality locally. Maybe eventual question is like, how do you differentiate yourselves in this crowded market, if you will?
Right now, to me, today we are talking about the AI application, but what we are not talking about is other capability. I think the differentiator can be built on the other parts like enterprise scalability, enterprise features, security, compliance, and or even the customer service or the branding, the community ecosystem. And I think the differentiator for the database, it is not a very simple, or there is not a simple answer to this, but it is like a very for different customer or different scenario, we have very different value to these different customers. So yeah, I'm thinking that's why we want to build a unified platform. At least one of the trend we can see is the people tend to use easier solution, and they don't want to spend a lot of time in infrastructure or complicated technologies. So yeah, that's what we are trying to do. Okay.
Cool.
Yeah.
James, maybe this is a question for you.
Yeah, I actually have a
Can
different
we
answer.
apply? Please go ahead. Sorry.
Oh yeah, so quick answer is that we think semantic or vector search are gonna be very different as it for now. So yeah, for SQL databases, we have join, we have group by, we have all kinds of different functionalities, and we thought vector DB is gonna have the same functionalities. So think of what happens if a vector group of vectors can join with another group of vectors. It's definitely not exact match. It's still going to be semantic join, right? That we saw actually one use cases, right? You have a bunch of boys and a bunch of girls, and you want to mapping them all together, and it's very similar to a semantic join. And you can also do a semantic group by, right? You have a bunch of dog images and a bunch of cat images. So when you do group by, what happens? So all the dog images actually group by to one group, and the cat image group by to one group. So that is going to be very important.
But to me, just like I said, it is more like introducing a new building function to the SQL, like the semantic group by. And all the important part is the implementation. So yeah, that's. But from the language perspective, today, just like I said, the SQL is still the most popular query language in the database world. So yeah, that's okay.
James, we have a question on, can we apply explainable AI combined with vector DB search?
Yeah,
Maybe this is a broad question.
Yeah, I thought it's already like vector DB helps a lot on the how to keep like your AI applications in control, right? React is definitely built for that. So you can also instead of just doing hallucinations, you can also have a lot of reference links. So that helps to explain what happens. But I thought right now it's probably not going to be enough, because even for vector DBs, it's very hard to trace why this chunk is actually picked up, right? Why they have very similar scores, right? So that's why we also want to have different kind of embeddings. If you take a look at what Cobert are doing, so they are token level embeddings, and they can highlight, when you search out some of the documents, they can also highlight why this chunk is actually picked up, because of some of the keywords is actually matters in this chunk. So with Cobert, with sparse embeddings, then the answer can be more explainable, and you can also like change the weights of each the keywords. So it also like make your answer a little bit controllable rather than just using density embeddings.
Yeah, I agree. Yeah, and James made a perfect answer on this. I want to add one comment. We also find this it's very important for the user or developers build RAG or other AI applications, how to explain the result generated by LLM. So that's why we introduced the knowledge graph, and we want to show the whole process, how the data that's used by the LLM to generate the result. Yeah, so trying different approach. Yeah.
Okay, perfect. Last question is, what type of index types are supported by TiDB for the vector database?
Index type support. I consider this question, if I understand correctly, what is the index data structure in TiDB vector. We use HNSW, L1, L2 cosine distance. It is very common used, widely used in the vector database community. HNSW, yeah, in memory.
Cool. Those were all the main questions. I'm sure I covered all of them. The others are, some of them are comments, and others we have addressed them through text. I think that concludes the panel and the Q&A. Unless other folks have more questions, we reached the end of the webinar. Thank you all for joining us for today's insightful discussion between James and Ed. We hope the comparison of these two vector databases and the distributed SQL database with vector search has provided you valuable insights. Special thanks to both Ed and James for their expertise and thought-provoking perspectives. If you can scan this QR code if you're interested in trying out vector search private beta within TiDB. We will be releasing it in public beta at the last week of this month, June 26th to be precise. We have a webinar during that launch. If you're interested, please feel free to join that as well. Again, don't forget to register for that. And thank you for spending your valuable time during this webinar. Thanks all. Have a good rest of your day.
Thank you.
Thanks, Ed. Thanks again.
Thank you.
See you guys.